Hello everyone. From this session, we are starting system design. So we will try to understand everything about system design. This course or these kind of videos, I guarantee you that it will make you interview ready and it will make you understand system design end to end. So let's start with system design. So do you remember that on October 4th, 2021, Facebook, Instagram, and WhatsApp all went down for almost 6 hours. Billions of users couldn't access this platform. The estimated loss over $100 million. This was the estimated loss. Now, why this would have happened? The reason for this is a system design issue. A simple system design issue which lies in the configuration. A configuration change in their backbone network caused a domino effect that brought down the entire infrastructure of Facebook, WhatsApp, and Instagram. So just think of how important system design is. So in this video, we will try to understand what is system design, what are its components. It's a basic introduction which we are trying to understand in this session. So let's start with what is system design at first place. So what is system design? So system design is the process of defining how different components of system work together to meet requirements and handle real world challenges. Okay, I know that this all sound like a textbook jargon. Let me explain it with something you will actually understand. Think about building a house, and you are a coder, also a carpenter, okay, in this house. So if you are a carpenter and you want to build a house, what you will think is how this wall needs to be structured, right? What kind of door I should install here, what kind of window I should put it here, right? All these things you will think of as a carpenter. Now you are focused on the details of it, right? How it looks like. It is not a system design of the house. So system design, if you want to implement or if you want to do system design for this house, then you need to think like an architect. So you need to think how many people going to live in this house? 2 people or 20 people? What if there is an earthquake? What if there is an earthquake here? What will happen to my house? How to make this house sustainable? Do we have a special foundation? Where would we place the plumbing so it will be efficient? What happens when the family grows? Can we add another floor? Can we extend this house further if our family is growing? What is our budget? So do we need to have a marble floors or wooden floors? Where the electricity coming from in this house? So all these things we will think from a system design point of view. Now you will be understanding what is the difference between a coder and system designer or architect. Coder is basically, if coder is a carpenter, he will think of building walls, doors, detail. But system designer is an architect. He needs to think it like an architect. Entire blueprint, capacity and growth, everything he will think of from that point of view. So coding equals writing this function to calculate a user age, for example. System design equals designing how 500 millions can calculate their age with the help of the same function. So understanding the difference, if you are a coder, your focus is on writing a function which a user can use and calculate their age. But if you are a system designer or architect, your thinking should be how the function which I have written, how the 500 million users can use this function at a time without breaking the system. So that is the mindset of system design. So system design is about why, when, and what, and how is about how is defined by your coding, how you are going to build it. But what will happen when these many users started using it? All these answers system design will give you. So system design it is summarized actually here. System design is a combination of architecture, trade-offs and scale. So what we understood is key insight is good code makes feature work. Good system makes app scale. So whenever you will think of system design, right, you just don't need to think about a single user, right? That is anybody can design. And that's how the developer guys do it, right? They will tell, okay, if I want to design it, there will be user who will be using API gateway. There will be a service. It will hit it. It will connect to DB, bring the data and send it back, right? That's how a developer will think. But this is not a system design. System design will come into picture when you add the mindset like, okay, currently single user, right? Let us say there are thousands of user connecting, then how it will work? That is actually a system design. People will get confused. Every developer start thinking that I am also doing system design, but that is not the system design which he is doing. System design will come into picture when you think of scale, how to scale your application. That's where the system design come into picture. Now let's consider a real world example of system design. This is the best example in the history of system design of Instagram. So let me tell you a story that perfectly illustrates what system design is all about. That is the story of Instagram. So in October 2010, Instagram has started. They had a one server, one database and works for 100 to 1000 users. There were only 100 to 1000 users and it used to work efficiently with one server and one database. But 2 months later, it became very popular. Like Instagram became very popular. So 2 months later, their users has spiked to 1 million users. And the problem now is one server is not enough. This server is not enough. So application becomes slow. They have realized this problem and they brought a solution. This is a system design mindset which they brought. Okay, so how to scale the solution so that 1 million users can access it. So what they realize is, okay, problems where photo uploading was slow. Photo upload slow, right? Because of the huge user. So they brought CDN. So CDN is a content delivery network. It stores photos in multiple locations worldwide and it stores the photo near to the location. If user is in Tokyo, then the photo will be stored near the Tokyo server. So that gives user a fast upload and fast retrieval. And these CDNs are located near to the user. So if we have a user geographically present at a different location, we will have a CDN nearby that location. So it's like instead of one library in Bangalore, you have libraries in every city, right? That's what CDN does. And that's how they got a leverage. They solved this problem of photo upload, which was becoming slow. Then the second problem which they realized is their database was getting overloaded. And that is obvious, right? Because initially 100 to 1000 users supposed to work. Now 1 million users directly started hitting the database. So database was overloaded. So what they did is they implemented sharding. So don't worry if you are not understanding this concept, right? CDN, database sharding, load balancer, don't worry. We will understand it as we progress in this course. But I'm just explaining you how one problem can be solved with the help of different component of system design. So database was the problem. So they brought a sharding. So what sharding will do is a single database will be divided into the small part. And these each part serve as a read replica. So initially all users were reading from this one. For example, now some users can read from this, some user can read from this, some user can read from this, some user can read from this. So the user load is distributed and that's how the overloading problem is addressed. It's like you go to the bank and initially there is a one cashier. Now you have a 10 cashiers, right? So there will not be a queue at a single cashier, right? The queue will be distributed and it became more efficient. So it's like that. Then the third problem which they were facing is the server crashes in this. And that is also obvious, right? Because number of users has increased. So what they did is they brought a load balancer. So load balancer is the component which is responsible for distributing the load across the servers. So this is server, this is server, this is server. So if the request comes, it will forward it to this server. Second request comes, it will forward to this server. Third request comes, it will forward to this server. So it distributes the request. So that's how it is solved. So this is a brilliant system design. And since it is a brilliant system design, right? The Facebook acquired it in 2012 with $1 billion acquisition, and now it has become 100 times of it, right? So that is the benefit. If you are acquiring a product which is very good at system design technically, then you have a leverage. You can scale it massively, and you can see that it was working that time with only 13 employees. Nowadays you might be seeing that some companies has a project where they have hundreds of employees working for that single project, right? If there are many people working on this is a indirect signal that you might have a problem in your system design. Understand this, okay? It is a sign, it's a symptom. If you have more than 100 employees, 200 employees working on a single project, then that is the problem. Just think of Instagram has only 13 employees that time, handling 30 million users. It's unbelievable, right? So it's an example of best system design. Now next part which I actually kept is coding versus system design. This I think we have understood, but let's try to revise it. So when it comes to coding, right? Coding mindset is altogether details, is related to details, okay? So the mindset is related to how it will work for single users. It will restrict it to one feature. Then here the correctness is important. Then the question is, does it work? Will it work? The function, whatever I have written, will it work? And the timeline can be in hours or days. The example is sort function. For example, you are writing a sort function, then you will see that how it will work for single user. It might be a part of a feature. Then it should sort it correctly. It should work it. You should finish it in 7 days, like this. So implementation and code quality is important in coding. But when it comes to system design, right, you need to think all together how it will scale for million users. For example, Google search we are taking, right? So how Google search can work for millions and billions of users. Scope entire app you need to consider, right? You are not restricted to the single component of your application. Entire application has to work when millions user connect, right? The scope is entire application. Here you were only focused on a single functionality like a sorting function, but here entire app you are considered. Then concern is scalability. It should able to scale and handle that many users. You need to basically answer a question, does it scale? How many people, how many developer guys, you just consider yourself. Whenever, whatever you develop, have you asked, does it scale? Does your solution scale? Very rare. And whoever asks, right, those people are for them, it is easy to develop a system design thinking. So if you want to build a system design thinking, if you are a developer, then start asking, whatever you write, can it scale? That is the question you should ask. Then in system design, the timeline can be weeks and months because you need to think of a lot. You need to think of all the pros and cons, trade-offs, and evaluate the approach, right? And the focus is architecture and trade-offs. Now trade-offs, what I mean by trade-offs. So what happens is whatever application you build, right? Whatever decision you take in the application, sometimes what happens, you will get one benefit, but you might compromise on the second benefit. That is called as a trade-off. For example, your application should be available to user. Now application is available to user, but user is seeing the stale data, old data. He will not get the latest data very soon. So that can be a trade-off. Your application is available, but he is getting the stale data. Now, if you always want to show the latest data, then your application might not be available for some time, because let's say there is a breakdown, your application might not be available, right? So there is always a trade-off. This we will understand. Trade-offs we will understand when we understand the CAP theorem. Okay, so stay tuned for that. We will understand this also. Now, key components of system design. This is very important. So what should I learn? If you have a question, what should I learn in system design? Then these are the key components which you should learn. So key component of system design. So these are the things which you should learn, right? So first is architecture. So how you are going to define the architecture? So are you considering monolithic, microservices or serverless? So in monolithic, all your application code is a part of a single service or component. Okay, that is your monolithic code. Microservices means your application is divided into small modules or tasks, and each task is a service. For example, when it comes to Instagram, there might be a upload service, photo upload service, there might be a video upload service, there might be a video upload service, there might be a photo upload service, there might be a follower service, comment service, right? So it's a part of that. And there is a serverless. So serverless is something that cloud is, you are leveraging cloud, right? So all your components are lies in the cloud. So cloud handles the infrastructure. So you need to decide between these three. But in system design mindset, when it comes to service, right? So each service should be independent, scalable, and maintainable. So if the service follows these three, independent, scalable, and maintainable, then it is easy for the application to scale. Okay. The next component is data storage. How you are going to store the data? Are you going to store data in the form of SQL? SQL is a relational database. So for example, when it comes to Instagram, for example, the structured data, user profile data can be a structured data. It will go to relational databases, which is SQL, right? Then NoSQL. So feeds data, feeds, right? Whatever feeds you get, that might go into NoSQL database, possible. Then all your photos, that goes to your S3, which is a object storage. So you need to decide all kind of data which needed in your application and figure it out how we are going to store it, so that we can scale it, right? So hence data storage is very important. Next is data flow. Data flow is about how your entire flow, one particular flow, for example, how it works. For example, user is trying to upload a photo on the Instagram, right? So how it will happen? It will go to API gateway, for example. Then there will be a upload service which is running, right? There is a upload service which is running here. Upload service which takes photo, put it into the message queue. For example, this is a message queue. This message queue will send it to another service which will process your photo, right? And it will store it, for example, somewhere in the database, whatever is there. So this is a flow. So you should able to craft out the data flow. So data flow is an important component. Then communication. How are you going to design the communication between the services, right? So we have a synchronous communication, asynchronous communication, and real-time communication. So synchronous means you are here, there is another service here. I am representing it as part of user, but consider it as a service also. Okay. So you are messaging, you are sending message, you are waiting for the response. That is a synchronous. Second is you are sending, but you are not waiting for response. In the background, it might be processing your message here, and once this is finished, then it might respond you, and later on you will see it. That is a asynchronous communication. But I will not wait by that time. I will start doing my another task. But in synchronous, as soon as you send message, right, you keep on waiting for the respond. Real-time communication is like a WhatsApp communication. You have message from here, you will wait for the other message. You will instantly get the other message, right? Continuous chat. You are chatting here, you are getting it back. So continuous chat. So that is a kind of different ways of communication. That also you need to consider when it comes to system design. Then scalability. How you are going to scale. So we have a horizontal scaling, we have vertical scaling. Right? In vertical scaling means today you have a 4 CPU, 1 GB memory. Right? You will have you have done a vertical scaling, and now you have a 8 CPU and 32 GB memory, for example. So like that, you are increasing the size of your infrastructure. That is called as a vertical scaling. But horizontal is you are bringing more servers. That is a horizontal scaling. That also you need to consider. Then reliability. Reliability, when it comes to reliability, right, we have a replication, backup, health checks, and graceful degradation. So replication means what? I am writing into one database, but if this is the only database from where the people are reading, if something bad happens here, right, the entire service is down. So we need to keep on replicating the data into the multiple things. This process is called as the replication. Then backup. We also need to take a backup of the data. If something happens to this, we should have a data to restore it, right? Then we should have a health checks. Then graceful degradation. All these things comes under reliability. We need to think of reliability when it comes to system design. So these are the 6 components which we need to think thoroughly whenever we design the system design for any application. Now let's try to understand why system design so important. So system design has a business impact. So for example, if your design is poor, that's what happens. If Amazon, if the guy log in into the Amazon, right? A user log in into the Amazon and he tried to click on buy now, but there is a lot of delay in getting the transaction processed, right? Then he might leave that application altogether. And that's what actually happens. Amazon faces 1.6 billion loss per year if there is a 1 second of delay. This is a fact. Knight Capital, $440 million lost in 45 minutes. And this is because of system design. They did actually a bad deployment, and that's what actually happens. 45 minutes of disruption in the service because they did a bad deployment, bad system design deployment, and it costed them 440 million. So system design has a direct impact on the revenue, you can say. Good design, we have seen, right? WhatsApp, Instagram, those are like a very good design. Somebody bought it and they have scaled it like anything, right? So WhatsApp currently $19 billion, 50 engineers, and it is handling 900 million users. Discord is another social platform. 4 billion messages a day it handles. Then user experience. System design is linked to user experience. If your system design is strong, user experience will be pleasant. Because remember, users don't see your code, how strong your code is written, how well it is written. They experience your system design, how your all end-to-end application works. That's what they experience. So poor system design, for example, Instagram takes 10 seconds to load feed. Videos buffer constantly. App crashes during peak hours. What is the result? People will switch to TikTok. That's what happens. So 53% of sites which users abandon, right? Because they have a more than 3 seconds of load time. Just think of. And if you improve 1 second improvement, right? You have a chance of 7% conversion of that user into your buyer. That is the thing. And career growth. This is another aspect. So if you are a junior developer, right? Who writes a code, implement feature, fixes bug, salary will be around this much. If you are a mid, who writes better code, design individual features, mentors junior, salary will be this one. But if you are a senior engineer, 5 to 8 years experience in the system design, make architectural decisions, salary will bump up from 180 to $300K, right? And if you are a staff 8 plus years, then salary you can see the range, right? That's why system design is an integral part of all the FANG company, and nowadays for every company, they ask you the question related to system design. So that's why system design learning is also important for your own sake and for your project sake. Now, obvious question is, when should we start thinking about system design? When should we think about? So we need to think about system design from the start. Initially, what used to happen is, people used to gather requirement from the user. Okay, we will have a business requirement documentation, BRD, or they will call it as a PRD, product requirement documentation. Then it will go to development. Then the team used to think about system design, how it will work. But this is a flop plan. So you need to start, whenever you will start a new project, right? From that day itself, you need to start thinking about system design. How many users are expected? What is the infrastructure of budget? All these things you need to decide. You should have a clarity so that you can make a proper system design decision. But only thing which you need to be cautious is don't over engineer. Okay. Then hitting scale limit. In case your application response times are increasing with adding functionality, it is undergoing frequent crashes, database slowing down. If these are the symptoms, then you should consider system design. Then in interview also, they will ask you. So there also you need a system design. Team collaboration without So if you don't have a system design, everywhere there will be a conflict. Somebody will develop something like this which contradict with what other guy is developing. So that's what happens. So without a proper system design guideline, there will be team conflicts. But with a proper system design which is understood by everybody, right, there will be a clear boundaries, easy maintenance, and all people, whoever will develop, right, the developer, they develop as per the system design what is defined, right, in your application. So all can work in harmony. So you need a system design. So these are some of the terms of system design. You just have a look at it. Whatever we have discussed, all I have put it here for your information, but it's okay, those everything we will going to understand. So what are the key takeaways from this, right? So system design is an architecture planning of a scalable system. And one or two definition more which I want you to leave it with. System design. What about system design? So what is system design? System design is the art of planning software. So it works smoothly when thousands and millions of people use it at the same time. This is a system design. Another definition which I found is system design is not about drawing boxes, which many people think that, right? System design is drawing boxes, showing flow from going from here to here. It's not about drawing boxes. It's about understanding where the system will break when the user increases and fixing that before it actually breaks in the real time. So that is the part of system design, right? So this is what I want to cover in the session of system design. So stay tuned. We will going to cover a lot more in this thing and make you interview ready as well as system design knowledge ready.